All right, this question's got simultaneous equations involving logs, but before we get onto that, we've got part A to do. Now, I am making this video a much later point than this paper was released. When this paper was released, there was no log to base 2 button on a calculator, but now there is, and actually that is the best way of doing this question. So I'm going to do it that way, and I'm going to show you how to do it another way. Being able to do it both ways is important. So because I've got 2 to the power of n minus 3 as some number, we can take log to base 2 of both sides. Now, what you are asking here is like, what do I raise 2 to the power of to get 2 to the n minus 3? And the answer is, of course, n minus 3. So the left-hand side simply becomes n minus 3. The other way to think about it is that you can bring the power down, and then you just got log to base 2 of 2, which is just 1. But that's what we're going to get. And then n minus 3 is going to be whatever this is. And here it is, log to base 2 of 18,000. This gives 14.135, which means that n, I just add 3 on, it's going to be 17.135, which is going to be 17.1. Okay, let me just show you another way of doing it. This is how you would have to do it back in the day. Still a good method. Here you have to do log to base 10 of both sides. Actually, to be fair, it takes a bit longer. I'm writing log to base 10. Normally, if you just write log by itself, then that is the same thing. So now I bring the power down using the third rule of logs. So basically there's just this extra step, and then I divide. So n minus 3 going to equal log to base 10 of 18,000 over log to base 10 of 2. Now when you put this in your calculator, which I'm going to leave you to do if you want, you'll get 14.135, and then you'll just add 3 to it. So just takes a bit longer. Right, on to the main one, the one we've been looking forward to. Solve these simultaneous equations. Okay, so when you have simultaneous equations, you somehow have to combine them to get rid of one of the unknowns. Now I could like there's two different possibilities that might make sense. I could combine this into a single log to make 8, but then I've got another log that doesn't look anything like it. So I'm actually going to do the opposite and separate this log here. Because I'm dividing something within a log, I can actually then subtract the logs. That's the second rule of logs. Okay, and I've got to say, I quite like the look of this because I can now add. I mean, I could bring this 2 down. Maybe I should do that first. Yeah, I think I'm gonna do that. Just one extra step. Bring that 2 down so it'll become 2 log to base 2 of x. So now I'm going to consider this equation here. That was the one I had, and then this equation. Because I've managed to get a plus log to base 2y and a minus log to base 2y, I can add these two together, which is going to give me 3 log to base 2x equals 15. And that is really good because that's going to give me log to base 2x is equal to 5. So then basically x is going to equal 2 to the power of 5. You can get that just from like your understanding of logs. It's like, what do I raise 2 to the power of to get x? It's 5, so 2 to the 5 is x. Or this is also worth being aware, knowing you can raise both sides to the power 2. And these basically are inverse operations. Log to base 2 and 2 to the power of something cancel out. And that also gives you x equal to 2 to the 5. So x is going to equal 32. I'm not quite done. Right, I can just substitute back in, and it's going to make sense to, this is the simplest one to substitute back into. So log to base 2x, remember I know that is 5. 5 plus log to base 2y is equal to 8, which means log to base 2y is equal to 3, which means y is equal to 2 to the 3, which is 8. Sorry, I accidentally wrote equals twice. Okay, nice.